Welcome to the cosmic journey of epic proportions. Today, we'll unravel the incredible story of galaxy formation from the chaotic beginnings of the universe to the orderly dance of billions of stars. This is a tale that spans billions of years, filled with cosmic drama, collisions, and the emergence of the grand cosmic structures we see today. Let's dive into the mysteries of how galaxies like our Milky Way came to be. Galaxies are some of the most beautiful and awe-inspiring objects in the universe. They are not only visually stunning, but also hold important clues about the origins of our universe. In this video, we will explore the formation and evolution of galaxies, from the early universe to the present day. The universe began approximately 13.8 billion years ago with the Big Bang, a massive explosion that sent matter and energy flying in all directions. During the first few seconds after the Big Bang, the universe was incredibly hot and dense, with particles colliding and fusing to form the first atoms. After the initial explosion, the universe continued to expand and cool, which eventually allowed the first galaxies to form. In the chaotic early universe, matter was not evenly distributed. Tiny fluctuations in density caused some regions to have slightly more mass than others. Over time, these denser regions began to collapse under their own gravity, pulling in surrounding gas and dark matter. This process led to the formation of the first protogalaxies, small, relatively simple structures that were the precursors to the galaxies we see today. The first galaxies were much smaller and less complex than the galaxies we see today. Over billions of years, these early galaxies began to merge and interact with each other, gradually forming the larger and more complex galaxies that now populate the universe. One example of an early galaxy is UDFI 38,135,539, located approximately 13 billion light-years away from Earth. This galaxy is believed to have formed just 600 million years after the Big Bang. Compared to most galaxies we see today, UDFI 38,135,539 is tiny, containing only a few million stars. However, it represents one of the earliest steps in the process that led to the vast and intricate structures we observe in the universe today. Within these early galaxies, the process of star formation began to unfold, a key step in the evolution of cosmic structures. Stars are born in vast clouds of gas and dust, known as molecular clouds or stellar nurseries. These clouds are primarily composed of hydrogen, the simplest and most abundant element in the universe, along with trace amounts of other elements and molecules. Under the influence of gravity, regions within these clouds begin to collapse, causing the gas and dust to condense into denser clumps. As the material in these clumps collapses further, the temperature and pressure in the core increase dramatically. When the core temperature reaches around 10 million degrees Celsius, nuclear fusion ignites. During this process, hydrogen atoms are fused together to form helium, releasing a tremendous amount of energy in the form of light and heat. This marks the birth of a new star. The energy produced by fusion counteracts the force of gravity, stabilizing the star and allowing it to shine for millions to billions of years, depending on its mass. Over time, galaxies continued to evolve and change in remarkable ways. As they grew larger and more complex, new stars formed within them, adding to their brightness and diversity. However, the growth of galaxies wasn't solely due to internal star formation. It was also driven by the interactions and mergers between galaxies. When two or more galaxies collided, their gravitational forces intertwined, often leading to the formation of a larger, more massive galaxy. These mergers were not gentle processes. They involved intense gravitational interactions that could reshape the structure of the galaxies involved, sometimes triggering bursts of star formation. One notable example of a galaxy that has undergone multiple mergers is the Centaurus A galaxy, located approximately 12 million light-years away from Earth. Centaurus A is a giant elliptical galaxy, and its unusual appearance, a mix of smooth elliptical structure with a dusty lane of dark matter, provides evidence of its tumultuous past. It is believed that Centaurus A was formed through the merger of several smaller galaxies over billions of years. These past collisions have not only shaped its current structure, but have also contributed to the growth of its central supermassive black hole, which is among the most massive known, with a mass equivalent to billions of suns. This black hole is highly active, driving powerful jets of radiation that can be observed across the electromagnetic spectrum, making Centaurus one of the most studied galaxies in the universe. Today, billions of galaxies populate the universe, each with its own unique characteristics. Some galaxies are spiral, like the Milky Way, while others are elliptical or irregular in shape. Galaxies vary greatly in size, from small dwarf galaxies to massive supergiant galaxies. An example of a massive galaxy is IC 1101, located approximately 1.7 billion light-years from Earth. It is one of the largest known galaxies, with a diameter of about 6 million light-years. As the universe continues to expand, galaxies will continue to evolve and change. Some galaxies will merge with one another, while others will be torn apart by gravitational forces. New stars will continue to form, and old stars will eventually die, leaving behind remnants such as white dwarfs, neutron stars, and black holes. An example of a galaxy that is currently merging with another galaxy is the antennae galaxies. These galaxies are located approximately 45 million light-years away from Earth and are in the process of colliding with one another. The collision will cause new stars to form and will eventually lead to the creation of a single, larger galaxy. Now, let's explore how galaxies are formed. It all begins with massive clouds of gas and dust drifting through space. In the early universe, tiny clumps of matter began to come together, gradually forming larger structures. As these structures grew, their gravitational pull increased, drawing in more and more material. This growing clump of gas and dust gets squeezed tighter, raising the temperature until stars start to form. These new stars shine brightly, releasing a lot of light and energy. This energy pushes some of the surrounding gas and dust away, which helps control how quickly new stars are born. The light from stars transforms the nearby gas and dust into what we call the interstellar medium. This medium is essential for creating new stars. Over time, it becomes richer in heavier elements, which are necessary for forming planets and other celestial objects. Eventually, galaxies collide and merge, creating even larger and more complex structures. These mergers lead to new stars forming and the birth of new galaxies. The incredible story of galaxy formation is just one piece of the vast cosmic puzzle we've explored today. But this is only the beginning. If you're excited to dive deeper into the mysteries of the universe and the wonders of science, make sure to check out our other videos. If you enjoyed this one, don't forget to hit the like button and subscribe to our channel so you never miss an update. Stay with us as we continue our cosmic journey.